All right, let's talk about an introduction to probability. We're also going to talk about the additive law and the complement rule, which are some logical consequences of how we talk about probability. So a probability is just the number of successful outcomes divided by the number of possible outcomes. This is always going to be a number between 0 and 1. So if you have something that's definitely going to happen, a certain event, it's going to happen 100% of the time. That's 1. An impossible event would be something that can never happen. It's going to happen 0% of the time. Therefore, our probabilities have to be between 0 and 1. Okay, so any probability that we talk about is always between 0% and 100%. We can say the probability of event A happening is the number of ways that A could happen out of the number of possible outcomes that exist in this universe. Now, a logical idea that connects to that is what we call the complement rule. If you talk about something happening or something not happening, it has to add up to 1. So if there's 5 out of 10 ways for A to happen, then there has to be 5 out of 10 ways for it to not happen. Likewise, if there's 3 out of 10 ways for A to happen, then there has to be 7 out of 10 ways for not A to happen. If that doesn't work out, then the way that we're talking about probabilities doesn't make any sense anymore. Let's do an example. There's an experiment where we're going to toss a 6-sided die that is unbalanced. Now, this takes a little bit to wrap your head around. We're going to have a not fair die, meaning that we've broken the rules of how dice actually work out. Our sample space is just going to be 1 through 6 because it's a 6-sided die. But the event probabilities, we've made them up like we've observed them. Getting a 1, you've got a 20% chance of getting a 1, and you've got a 25% chance of getting a 5. They're not equal. Okay, and again, we've made this up. This is a made-up die. This is not a real die that we're tossing out there. We should probably also notice that we've got some pretty extreme differences. Only a 5% chance of getting a 2. Find the probability of each one of these events. So the probability of A, which is an odd number, we're going to be looking for our sample set out of this. So what are the possible ways that we can do that? Well, the possibility of rolling an odd number, we could have the probability of getting a 1, the probability of getting a 3, or the probability of getting a 5. So the probability of getting a 1 is 20%, of getting a 3 is 30%, and the probability of getting a 5 is 25%. Now, I'm just going to the table to get those values, and when I add that up, let's see, it looks like I get a 75% chance of getting an odd value. Okay, that's really different than using a standard fair die. Okay, let's take a look at the probability of getting an even number less than 4. Okay, I got to picture this. So that's the sample set of, okay, even number less than 4. Oh, 2. I think 2 is the only one that works there, right? That's my sample. So I need the probability of B, and it turns out to be just the same thing as the probability of getting a 2. And from the table, that's just 5%. So, probability of C, any number greater than 2. Okay, so any number greater than 2, that says I can't use 2, so I could use 3, 4, 5, or 6. Okay, so I'm just shrinking down my sample set. And it looks like I can go in and say the probability of C is therefore the probability of getting a 3, the probability of getting a 4, plus the probability of getting a 5, plus the probability of getting a 6. From the table, that's going to be, let's see, 3 is 0.30, that's right there. The probability of getting a 4, a 5, and a 6. And I hope you're working these along as we go. And I get an answer of, oh, that's interesting, 75% again. Okay, so the probability of getting an odd number and the probability of getting a number greater than 2 with this particular die that we made up turns out to be equal. That's a very odd situation to be in, isn't it? Let's do another example. This one's more of a real-world one, less of a constructed one to make our point. We're going to toss 2 dice. We're going to add the values. So how many outcomes are there? Well, okay, tossing two dice, if they're fair dice, fair balanced dice, there's 6 possible outcomes on the first die and 6 possible outcomes of the second die. The fundamental counting principle says we just multiply them together, so there's 36 possible outcomes. So I'd like to create the sample space of these events. And to do that, well, I'm going to say, what happens if we roll a 1 and a 1? We get a sum of 2. If we roll a 1 and a 6, we get a sum of 7. And if we roll a 6 and a 1, we get a sum of 7. So I'm just going to go ahead and fill in this table. You should do the same. All right, you may have noticed that I filled this in a particular way. I'm going to be able to take this and calculate the probabilities of getting each one of those events. So over in this table, I'm going to fill in, okay, the number of ways that I could get a 2. There's just one way that I could get a 2. And there's just, let's see, 2 ways that I could get a 3. So I'm counting up how many show up in the table on the left and writing them down on the right. Okay, when I do this, I find that there are, in fact, 36 different possible outcomes adding up this entire table. I could also calculate the probabilities, therefore, by saying there's 1 success out of 36 possible outcomes. And to get a 3, there are 2 possible ways to get a 3 out of 36 possible outcomes. So I'm using that definition of probability that we had up at the beginning. Let's go ahead and finish the rest of this table. So this table allowed us to build up and calculate all of our possible outcomes. We also have all of the probabilities, and we have mapped out all the possible events in sample space that we could possibly need for 2 dice. Let's explore some of the ways that we could use this information now that we have it. So let's find the probability of an event getting 10 or less. So we might have a situation of, like we have to count all of this up. We're looking at the probability of 10 or less, which means we're looking for getting a 10, a 9, an 8, 7. Oh, this is going to be so much. There's so many of these that we have to do. 6, 5, 4, 3, 2, 1. So we'll need to add up all of those. I don't really want to do all of the writing, but I believe that we end up getting, there's 33, I believe. Now, this isn't necessarily the best way to do this. We could come at this from a different direction. We could say the probability of the event happening and the probability of it not happening have to add up to 1. Therefore, 1 minus the probability of an event not happening is the same thing as the event happening. So I could say the probability of 10 or less is the same thing as 1 minus the probability of more than 10. That's much easier to calculate because I just get 1 minus the probability of 11. Let's see, I'm going to have to bracket this, plus the probability of 12. So this is going to be the same exact thing. It's basically on here. Instead of adding up all of that, we could just add up here and get exactly the same result. So I could say 1 minus 2 over 36 minus 1 over 36. See, that's 36 over 36. Yeah, that turned out quite nicely. Okay, so that's a trick using what we call the complement. All right, let's take a look and see if we can figure out what happens with the probability of A. So A is the sum of 5. So what's the probability of A? It's the same thing as the probability of rolling a 5 overall. So I got to look this up. Oh, this looks like that's 4 out of 36. This turns out to be that, so it's about 11%. Okay, any one of those answers I would be fine with. So the probability of B, when B is rolling an odd value. Okay, so I'm looking for the set, so an odd value, 1, 3, 5. So the probability of B is just going to be the probability of getting a 1, the probability of getting a 3, plus the probability of getting a 5. I can just add those together. Okay, so that means probability of getting a 1. Oh, wait, that's not right, because that's an odd value just on one die. I need an odd value overall. So I'm going to erase that. So I need the probability of rolling an odd value on 2 die. So that's a 1, 3, 5. Wait, I can't get a 1. I can only get a 3. 5, 7, 9, 11. And that's as far up as I need to go. So I need to get the probability of a 3 plus the probability of a 5 plus 7 plus probability of 9 plus the probability of an 11. And let's take a look and see what we've got there. Oop. See, this is all out of 36, so I'm just going to write the numbers. Let's see, it's 2 plus 4 plus 6 plus 4 plus 2. And let's see, that's going to give us, let's see, 10, 16, 18 out of 36. That's 50%, isn't it? Let's take a look at the probability for C. At least one die shows a 4. This is a different question, isn't it? So we could have anything with a 4 and some number, or anything with some number and a 4, where I'm talking about the first die and the second die. So this actually doesn't help to look at the events in the table here. It's going to be better to look at this table, just anything that has a 4. So any of those, or any of those. I could probably count that up, right? Because I can just use my definition. So I've got 6 ways for one, 6 ways for the other. Oh, that feels like it's too many, though, because if I just highlight, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've already counted that one. 10, 11. I should have 11. And it should be out of 36 because that's how many outcomes there are. But why did something strange happened there. And it's because I need to use the additive law. I needed to use the additive law in a different way. I needed to combine and take into account when they're both 4. So I lost one off of that. Okay, so let's do when it's the probability of D when D is a sum of 8. Well, the sum of 8 is just the probability of getting an 8. Let's take a look. Probability of getting an 8 is right here. So there's 5 out of 36. 5 ways to do it out of 36. Now that was it. That's the whole thing. Doesn't simplify or anything. All right, now I'm looking for the probability of A or D. So A was sum of 5. So the probability of 5, or the probability of D was, getting a 5 or an 8. I just need to take those answers and add them together, don't I? Because it's just join them up. You can't get a 5 and an 8 at the same time, so there's no overlap. So let's see, probability of a 5 was 4 out of 36. The probability of an 8 was a 5 out of 36, so I get a 9 out of 36 is my probability. That's, what, 1/4? That's not so bad, is it? Next question, find the probability of getting a 5 and getting an 8. Well, that doesn't even make sense. There's no successful ways to do that. So that's 0 out of 36. So my probability is 0%. All right. Last but not least, find the probability of getting an A. Probability of A. Okay, so that was getting a 5, or the probability, what was B? Or odd. Oh, this is going to be a little bit tricky. This is going to be more complicated. Okay, so a 5, that's the set. And if I join that with the set 3, 5, 7, 9, 11, you can see that joining those two together just gives me the set 3, 5, 7, 9, 11. So it's really just the same thing. There's no combination there. So this is just going to be my answer to B, which was 18 out of 36. Okay, so let's take a look at this additive law, which you need to make sure you've got in your notes. Okay, so if you take the probability of A and you add on to it the probability of B, you'll notice that we have an overlap right here, which gets counted twice. So that's why we're going to subtract off the place where we have an intersection, where they're both true. So if you want to take two items, you can say, just add the two together and subtract the ones that are in common. All right, that should get you covered for most of the lesson. I look forward to seeing your homework and taking your questions during class.